The session 2 of day 2 is going to begin. I request everybody to assemble in the auditorium.
Yeah. Madam,
Good morning to everyone present here. It's my privilege to introduce our distinguished speaker, Dr. Murali Loganathan, co-founder of Spirala Innovation. Dr. Murali holds both his master degree and PhD from IIT Madras and is a highly accomplished professional in the field of innovation, research, technology, and consulting. He has extensive experience in building innovation ecosystems, startup accelerations, strategic partnerships, and AI-driven solutions. Before co-founding Spirala Innovation, he led the AI fundraising, product, and marketing function at Private Circle and successfully established the Target Accelerator program, helping startups transform innovative ideas into successful venture. Today, he will deliver an engaging session on research integrity and AI tool, where he will discuss the ethical use of AI in research, academic integrity, and practical AI tools for responsible research. Please join me in giving a warm round of applause to welcome Dr. Murali Loganathan. Welcome, sir. We are honored to have you with us.
Going to the presentation and introduce myself. So right now I'm teaching at IIT entrepreneurship course that is on startup change to character. I've been on the last 5 years, and typically students will come in, and by the end of the course they actually have some sort of a product, some sort of a business model, some way to actually reach out. Are you able to hear me? You are able to hear me okay now? So the course is actually oriented towards startup founders. That's what it is. And after teaching 4 years, I thought maybe after teaching I should do something meaningful, and I also started a company. So that's what happened in the last semester in the course. So this company that we began is actually in the AI field, but oriented towards R&D teams. So R&D teams in say large engineering companies like LNT or chemical industries or Reliance. These type of people invest a lot of money into R&D, but structured tools for doing research and development is obviously changing, and AI changes this a lot. So we are building tools for R&D departments, hopefully short-term problem solving as long-term ones. That's basically what it is. So the first tool that we have developed is in trial with a couple of customers. It's very early stage, and the second product is also up and coming. So that's basically the stage that we are in. So in a sense, with respect to AI, my experience is limited to the product development that we are doing at this point in time. And of course, as a researcher, done my PhD at IIT, Professor as Muthu sir has previously spoken. So experience in research for me is like little about 10 years, but probably looking at the group here, I'm more of a junior to you guys from a research perspective. So I talk more from a personal experience as to what exactly that you can take away from my experience. Why it give the story first. It is split into three sections. So first section is of course what is research supposed to be? I mean, how many of you in this room are active researchers, writing papers, doing desk work, writing analysis and stuff like that? How many researchers here? Like one. So one, three, four. How many online? Can we ask this question online? So assume there is about another equivalent 10 people. So there's about 15, 20 researchers out here. So the talk is actually towards that 20 people only. And what is it that we are doing as supposed to be doing as the research? And prior to AI also research as a process was a little bit broken in the sense several things were broken and we want to talk about some of those and then together. But what actually has changed since 23 when AI tools have become pretty common from a research perspective. So that's basically the structure. But I will orient it towards my own experience. So I'll go with my first story. And so this is actually first question. Why bother doing research? I mean, why bother touching things that we don't understand? And by that time, I had made a decision to join IISc, and several different talks used to happen in the institute. I mean, of course, it's a research institution. At that time, we had about 2,500 students. Reduced the 600, 700 people in the UG and PG. About 1,800 students are actually PhD scholars in the institute. So on a daily basis, a lot of colloquium, symposium, talk, invented papers, etc. keep coming. While I was reading, actually, I don't even understand the title of the presentation. So I actually asked the question to Banu ma'am, who was actually office stenographer and has worked with a lot of researchers. What is the point of me attending these talks? I don't even understand the title. Forget about me understanding and getting anything out of the talk itself. So Banu ma'am's response is actually very simple. So you have come here as a PhD scholar. If you already knew everything, why did you come here as a research scholar? So the research is the first step is basically we have committed ourselves towards understanding something that is unknown. And that is the main thing. And if you are seeing people putting that effort around you to actually try and understand what is unknown, why are you not even going there and taking that effort? And that is very important. In this session, for example, FDP also, maybe you all know most all the methods that is required. Why is it that we are the earnestness to learn, being curious, actually trying to understand the unknown. That's the main thing. And if I'm still unwilling to learn, right, I have no hope. And coming from industry and joining PhD program and not willing to learn doesn't make sense. So I started attending a new stuff. So this commitment to the unknown is the first thing that we need to understand. And what is this unknown? So really, if you look at it, yeah, so the two things that we don't know. So what is the unknown here? Right? So unknown is either the phenomenon itself. So for example, you may be a civil engineer, you may be a AI scientist, you may be a material scientist, you may be a biologist, whatever it is. So there is a phenomena that we don't understand fully, and we need to understand what is happening. There may be a desk work, there may be field work, there may be measurements, there may be telescope, microscope, whatever form of measurement that we do. That is the first thing that we don't understand. And the second thing that we don't understand is somebody else has written a theory about that phenomenon. We don't understand that theory better. We are trying to figure evidence for that theory. We are trying to get for or against evidence of that theory. This is more desk work. And right now, if you look at it, the orientation of students, in fact, this audience itself is proving the point is that most people want to stay towards the theory that they understand. While coming, Murthy sir was telling this only. We teach 30 years of civil engineering, but there are very few people who can actually go to the field and measure. So it's very easy to be on the right side, understand very clearly also. In the sense, like, I think the studies of it. This is a very old concept. It's probably 1800s or 1900s. Johari started this. This is a two-way axis. So known, unknown, known, unknown. Basically, that is what it is. Known to me, not known to others. Is basically only you. As in, what is your basic thing. Known to you and known to others is basically everybody knows that. So there is nothing even there. unknown to you and unknown to others. That is basically the zone that is the biggest zone. So when you are imagining this, right, I mean the size of it is important because when you put a 2 by 2 matrix, you assume that all of these 2 by 2 cells are same size. But the unknown, I will give you a good analogy here. So suppose you have a A4 sheet. That half the page you draw sun and you draw earth in that page. You are able to imagine this. So there's the A4 page, half of it is sun. You put a earth, right? That is the scale that we are talking about between